Hey everybody, Miss Lowe here. This is the second video of our Algebra 2 Chapter 3.3 Solving Systems of Linear Inequalities. In the first video we graphed basic linear inequalities and we used a test point to determine if we shaded the correct area and if we had the correct solution area. You're trying number 2 at the top of the second page. Then we figured out where do the two boundary lines intersect, and we went through that for the first system of inequalities. We determined that it wasn't a solution because it satisfies the first equation, or excuse me, inequality, but not the second. And you're supposed to do the same thing for number 2. Determine where the lines intersect and whether or not it's a solution. So this is going to lead into applications of systems of linear inequalities and linear programming, which is the next unit, which is pretty hefty in terms of the number of steps, but this gives you a good start. So it says Beth is selling candy apples, I'm going to underline that, and made to order apple cider at the fair. She has at most 250 apples for her candy apples and her cider, which requires 3 apples each. So in other words, it takes, she has 250 total apples, and for every candy apple, that's 1 apple. But for every cider, that's 3 apples. And when you add those up, it can't be bigger than 250. So right there, we have a constraint. Because if we let x equal the number of candy apples, because we don't know how many she is going to sell of each, and y equals the number of ciders, we can figure out the possible combinations of candy apples and ciders that would work for this constraint. So again, for every candy apple, there's only 1 of those, so 1x. But for when she makes ciders, it's 1 plus 3y. And she has at most, so no more than, less than or equal to 250 apples. So that's one of our constraints, her number of apples. The next sentence says, each candy apple sells for $2 and each cider for $3.50. She needs to make at least $350. So there is our second constraint. So she makes $2 for every candy apple, $3.50 for every cider, and she needs to make at least, that's bigger or equal to $350. Now, she has to sell a positive number of apples, candy apples, and a positive number of ciders. So these two inequalities will be included in all of your linear programming problems. Basically, they're just telling you that you have to have positive answers. This tells you that your answers are always going to be in your first quadrant, which is that right-hand quadrant right there. So I graphed these on Desmos, and I'm looking for where the shading overlaps, and that will show us the combinations of candy apples and ciders that she can sell that will fit both of these criteria. So Desmos is great. It can do inequalities as well. So I typed in the first inequality and the second inequality, and now I can see the shading. So anywhere in this region, this is your first quadrant right here, anywhere in this region is a possible solution. Remember, x represents the number of candy apples and y is the number of ciders. So it looks like she should be able to sell 100 apples, candy apples, and about 50 ciders. That point right there. So let's use that as a test point and see if that works. Or we could do, she has 150 apples, candy apples, and she could do 20 candy apples. So we could do that one as well, 150 and 20 if you wanted to. Any point in this region we could test. So let's test 150, 100 comma 50. So a test point would be 100 and comma 50. So 100 plus 3 times 50, is that greater than or equal to 250? Or excuse me, less than or equal to 250, that would be exactly equal to 250. So that is a solution to the first one. And then plugging it into the second one, is that greater than or equal to 350? And that would be 200 plus 150, 2.5. That is indeed equal to, greater than or equal to 350. So this is a possible test point, and this is a possible solution. Any point in this region is considered a solution, a combination of number of ciders and apples. So that's a linear application. So geometry application, this is just basically graphing the system of linear equalities and determine what kind of figure is created. Again, you're looking for where the shading overlaps. Number 1, I want you to try on your own, but I'm going to do number 2 with you. Now, I'm going to do it on Desmos, but you need to put it on this graph. But I'm going to do it quickly so you can see it on Desmos. So I'm typing in all 4 of the inequalities that we see in number 2. And this is a great tool for checking. There's y is less than or equal to 4. Y greater than or equal to -1. Y less than or equal to -x plus 8. And y is less than or equal to 2x plus 2. So where the shading overlaps is the solution, and it's sometimes very difficult to see. But if I zoom in, I can see that the shading overlaps in this area right here. This area right here. So what this is forming is a pentagon. So this is the actual solution to the system of inequalities. So it forms the solution area is actually a pentagon. So I want you to make sure that you transfer these equations to the next page and that you graph it accurately and that you indicate that it's a pentagon, the solution area. So make sure you have this graphed and shaded. And then you're going to also graph these and determine the geometric figure that is created as well. All right. We will answer questions on the note guide next class, and then you guys will be working on the 2 problem sets. You're welcome to get started on those because they are due the day of class that evening. Hopefully this helps, and we will talk more next class.